which I think could be very useful for you. But let me just lecture a little bit, which I haven't done that much. Let me talk a little bit about uh, RAG. What are the problems that it's going to solve? And then also, I think potentially we could talk about some of the other interesting things that are happening in terms of the AI space as well. So one of the things I wanted to bring up was this concept of what even is generative AI. I think we're getting to a place now where there's been a lot of, and feel free to interrupt as well, because this potentially could be things that you could be asked on a job interview. They're very timely topics. So the I think what we're hearing right now is very different than maybe what we were hearing like a year or two ago. And this does relate again to RAG. Just give me a little bit of time to build up to it. But basically, we're hearing maybe a year or two ago that essentially the equivalent of an alien species was discovered on Earth, and that superintelligence was coming any day now, and that we should be prepared. Right, the whole world was going to change. AI technology that's smarter than PhDs. It was going to replace all workers. You know, we would have to give people universal basic income. And it turns out that at the time, I think this was about 2 years ago, I gave a talk at a conference and I was one of the skeptics. I think there's people that are much more famous than I am and they have much more experience than I do with AI. Even though I have a company that has AI in the title, I would still say like I'm maybe slightly above average. There's people who are way better than me at AI. But some of the same people who were critics, I agreed with a couple of years ago that we really don't have AI. We have essentially a different technology. And I would coin the phrase, we have not generative AI right now, we have generative search. So if you look at a search engine and you look at how useful it is, of course, it's incredibly useful. When search engines first came out, there was Yahoo search, which was not that great. And then Google search was the competitor that came out. And then Google search was able to really change the game because you're able to easily get good results. You could find useful information. And then potentially people were able to use that information they retrieved to solve problems, right? Like, hey, what's the best restaurant? Or, how do I solve a particular, technical problem? And then you see other websites like Wikipedia who had crowdsourced information. Those became very useful. So really the search type technologies were extremely helpful in the early phases of the internet. And I think what we're seeing now is that, in fact, in many ways, we don't have AI, we just have a different kind of search. And so, if you look at what generative AI really is, it's not intelligence, it's not logic, it's not solving math problems, it's not doing things that require very complex critical thinking skills. All it's doing is it's searching for information that it previously had indexed, and then it's retrieving that information and in some cases predicting what it is you're searching and then giving you the rest of it almost like a spell check or an autocomplete. So if you frame generative AI in that way, I think it's a very good way to understand where we're currently at in 2025 and likely where we will be in, let's say, a couple of years. Is we don't have any form of intelligence. We just have a brute force tool that's not smart at all, but that is also very useful. So in the terms of the coding sessions that I've done where I'm talking about hey, let's build this tool or let's build this. Notice even you've seen, like, I mean, I have a lot of experience building software, but I make mistakes and the tool makes mistakes. And then the mistakes could turn into like larger and larger problems that could cascade into real big problems. So, for example, if you're building a tool that makes one wrong suggestion to you and then you don't understand it, you could potentially destroy your company, right? Like if you push that change into production and it turns out that it's a change that was not a great change, you've completely destroyed your entire company. So we that kind of gets back into what we are talking about with cloud computing, is that we use all these DevOps principles with cloud computing, like continuous integration, continuous delivery. You're looking for quality control. You're doing DevOps best practices where you have microservices and you have logging and monitoring instrumentation. But likewise, why are you doing all those things? You're doing all those things so that you can manage complexity and control it. And you can look outside of the software industry for similar patterns. Like, for example, we have Toyota, which I think is one of the more interesting ones to look at. They have something called the Toyota Way. With the Toyota Way, they've been able to institutionalize quality control. And the institutionalized quality control uses phrases like, um, uh, Poka, I think it's called Poka Yoke, which is I could be pronouncing that wrong, but it's something like that, which is look and see, right? Or I'm sorry, idiot proof something. Or they have, I forget how you say it in Japanese, but like look and see. Like they have all these kind of paradigms. And if we summarize all of it, what is it about? It's about reducing the risk, making things more high quality, and controlling for defects. That is the essence of software engineering. So now, if we put inside of that tools like generative AI, what are generative AI tools good at? Well, let's first change the word and not call it generative AI. Let's call it generative search. What is a generative search type tool good at? Well, it's about creating things. So in some sense, you could say that it's a defect creation tool. So it doesn't mean that it's not useful, but if you don't have those Toyota Way type constraints where you look for quality control, you don't have DevOps constraints where you are able to test your changes, make sure that there's integration points, then a tool like that will be very dangerous. And so I think that's really where we can focus and then get into RAG a little bit, is that if we can, for the sake of argument, say that generative AI technology is is not even AI, it's just a fancier form of search that can do pattern matching and then create new content or create predictions based on what you searched for or the context you've given it. We know that potentially there's some real problems with that. And so we know that hallucinations, quality control, et cetera, are one of the issues. So there's a couple different approaches that we could use to solve it. We know that, for example, with the automobile industry with Toyota, they came up with this whole quality control system called Toyota Way, and that's why Toyota has the best quality of any automobile in the world. And they've been doing this from, I think, the 70s. They've had this whole methodology that makes the Toyota vehicle so powerful. But likewise, the software industry has come up with techniques called the Toyota Way, or called DevOps, where people also do quality control. They're able to use these to reduce the quality. So then now, if we get into RAG, in some ways, it has some of the similarity with DevOps or Toyota Way, in that the idea with RAG is that you want to reduce the hallucinations. So, how would you reduce the hallucinations? One of the ways that you could reduce the hallucinations is that you generate your own data that lives inside of this vector database, so that when you do a search, it can only return back results that are found within that vector database. So then, if it does a prediction, the predictions are things that you yourself have put into the vector database. So again, if you think about generative AI and you call it generative search, it starts to make more sense now, because if you think about what RAG is doing, it's like telling a Google search, hey, I want you to only look at Wikipedia when you do a search because I want the results just from Wikipedia. So likewise with a RAG database, a vector database, you're saying, look, I want you to do the things you're doing with search and with generation, but I want you to do them specifically within the context of the data that I've given your in this exact vector database. So does that hopefully that makes sense to people that in many ways a RAG database is got historical um, uh, lineage from the automobile industry and also from cloud computing and DevOps, software engineering best practices, but also search. Now, let's talk a little bit about the theory and the math behind what actually is going on with RAG. So, if we look at RAG from a mathematical standpoint, it has a lot in similarity to a collaborative searching algorithm. And so the way a collaborative, filtering algorithm works is that you take, let's say, people in a social network, you take 100 people that someone's following, and then you have another person that is following that person, and that person has 99 out of the 100 people in common with the person that they're following. And so what you could do for a recommendation is say, look, there's 99% similarity between this person and the other person. So if they're following somebody, I probably would want to follow that person too, right? That's kind of the intuition behind collaborative filtering algorithms is it's just a correlation, right? Like you're basically saying, hey, these two things are very similar, so let's just return back a recommendation that shows the person something they probably would like. And that's also one of the problems with social media is they call it filter bubbles, where people start to aggregate towards a certain type of topic or view, and then people really start to focus only on a certain type of information. And they could, if they lack critical thinking skills, lack data science skills, really be fed a certain stream of information and even radicalized. And even very intelligent people are potentially radicalized by social media. But how has it all happened mathematically? It's just from the vector database concept. So similarly, if we look at a vector database, which is the core foundation for RAG, it's the same thing. Is you're just looking at things that are similar, and then you're giving back a recommendation. So what we can do when we're building a RAG-based solution is we can effectively um, put content inside of a vector database and just say in a similar way to followers, we can say, look, is this text similar to this other text? And it's able to actually give you back similar pieces of information. Now, fortunately, a vector database also is very simple to understand. A vector database. A vector database is basically just columns in a spreadsheet. Like that's one way to think about it, is that columns and rows is that you're basically putting a bunch of features together like you would with Pandas data frame, and then you're looking at them and you're saying, look, here's all of the things in multidimensional space. In the case of a a um, a column in a spreadsheet, right? You're only looking at a couple different dimensions, but if you're looking at a vector database, you can look at in number of dimensions. So you could be looking at 3 or 4 or 5 different uh, values in in multidimensional space. And so as you put all this information inside, you're able to uh, get back similarities between things. So then if you look at the combination of both of those things, the RAG-based database is able to ground it, and then you get a search result that just uses those same generative search or generative AI techniques, and then gives you back the answer. So if we summarize and we just say, okay, well, why do I use RAG? What is the purpose of it? Like if someone asks you on a job interview, if you wanted to build one of these solutions yourself, it's pretty simple. You just want to ground the generative AI technology against a known quantity of data so that it only will return back results from that data set. So what are some of the limitations of RAG? So one of the limitations of RAG is that if you have a very small set of data, then potentially your tool that's using RAG will not be that useful, right? Like if you have only a very small set of, text, and you're asking it to generate, I don't know, customer service reports, or try to generate frequently asked questions or something, and you have the cold start problem, which is there's no data in there, then you effectively have not a really helpful tool. If you look at regular generative AI, because it can pull from terabytes and terabytes of the entire internet, it obviously could do a better job at predicting what someone is probably looking for. So that's one of the limitations of RAG, even though it can potentially be useful to ground the model on the fact that it can only look inside of that similarity database or vector database. The limitation, though, is that you better have a lot of data. And so now we have a kind of a secondary problem, which is, so can you even use RAG if you don't have a large data set that's been curated and that is a very high quality database that you could create yourself? So that's probably one of the more interesting parts of RAG, is that you could make the argument that you either have to select uh, databases that are publicly available and highly curated. Like, for example, I don't know, let's say it's like a food ingredients database. I mean, that could be kind of an interesting RAG solution, right? Is like, let's say you were able to look at, I've seen some in the past, some like highly curated food databases. You're able to say, oh, look at this, this food ingredient has this many calories or this much protein or fat or carbohydrates or sodium, etc. That could be kind of a cool thing to search into a RAG database, because you could ask for, healthy recipes or, something like that. But the problem is, there's how many um, problems lend themselves to that. They would have to have a publicly available data set. B, it has to be high quality. So that's one component. Now, if it's private, now if we get into the private problem, the problem is that you're going to need to have most likely a very mature company, because, and this does get into cloud computing a little bit, is that who can actually spend the time and resources to refine and curate all of the data inside of your organization? Well, probably only a very large company. I think many students in the MSBA program in particular, probably also some in the MBA program, have had to experiment with cleaning data yourself. The problem with cleaning the data is it could take 3 months. Like, I've worked on problems myself where I've spent close to a year, not full time, but like maybe close to a year, curating just like a small kind of problem I was trying to solve. So, I mean, how many years do you have of your life to do something like that? Like, let's say it takes 1 year for you to refine and curate the data. Like, realistically, could you solve two problems at your company? I mean, how many years are you going to be there? Maybe you solve five problems, or, so we have another problem, which is for the private company. A, you have to have the large data, and B, you have to actually clean it up and operationalize it. And so maybe even before you get to building the vector database with RAG, which again we'll do it next week, we'll write the code for it, is that the problem is that you may have to have cloud computing skills, you may have to have software engineering skills, and those cloud computing and software engineering skills would have to be applied, so that you would spend, let's say, 3 months going through and building out the quality control mechanisms to clean up the data, right? So just because there's a solution that potentially could be used with generative AI to ground the search results, it doesn't mean that it doesn't also introduce other problems. So I think that's typically the issue with technology, is that it's a little bit like whack-a-mole. So you say, hey, look, it would be great to get suggestions for something. So I'm going to use generative AI so I can get code suggestions, or I can use it to do customer service recommendations. But then you have the problem of it hallucinates. So then you go to the, okay, well, great. So I'm going to solve that because I'm going to use reinforcement learning, like they call it the thinking mode. But that doesn't solve all of the problems. So then let's go to RAG, and then you go to RAG, but then you have other problems that crop up, which is, can I get a public data set or can I get a private data set? And then in the case of the private data set, it also opens up problems, which is, hey, do you even have the data? And then the second component is, do you have the time to clean the data, and do you have the skill to clean the data as well? So I would say that's probably the way to think about currently the theory behind a lot of RAG. And also, now let's get into the actual, let, let's say that all that's okay with you. Now, where could you implement RAG? Let's get into that next. So because we've talked about AWS, one of the solutions that you can do, and I do have some material where I go through all this inside of the platform I gave you access to, that inside of AWS, they do have tools that integrate with Bedrock. And so let me just talk a little bit about Bedrock first here. I mean, and by the way, anybody can interrupt me anytime if you have questions. So let's talk a little bit about what is AWS Bedrock and why do you care about it? What problems does it even solve? And then again, how does that relate to RAG, right? Because we're supposed to be talking about RAG. So first up, what is Bedrock? So Bedrock is a foundation API. And the big difference with a foundation API is that if you use Chatbot Arena, I don't know if you've heard of this before, but Chatbot Arena is a tool that people use to look at what models have been performing the best on benchmarks. So if you believe me that models are not AI, they're actually search, you could just say who's got the most accurate search generation, right? So it searches for patterns and generates results. I mean, again, that's useful, but it's not smart. It's not intelligent. It has no concept of logic. You see that there's diminishing returns now. Everybody's essentially in equilibrium. And so you then go, well, look, why would I pick one model? Because maybe every 2 weeks, you know, they change places and they're kind of all the same. So instead, what you could do instead of using ChatGPT or Anthropic or Google Gemini or DeepSeek or Quinn or whatever, what you do instead is you talk to a service like Bedrock, and the Bedrock Foundation service lets you put in any model that you want. So if you think about it, that's kind of a better approach long term, is that instead of trying to bet all of the stuff you're doing on one particular company, you bet on the API, and the API will stay the same. So it means that you can have a unified way to access the model. And then basically you're able to query different models behind the scenes. You can say, hey, I want to query Anthropic, or I want to query an open source model like DeepSeek, or I want to query, some new model that comes out. And now that you've built this workflow, you could easily change based on price, based on different capabilities, et cetera. And so that's really the concept behind Bedrock, is that it's a service that lets you talk to different components of AWS, if that makes sense. Okay, so now let's get into Bedrock and RAG. So the other emerging components that we're seeing from Bedrock, one of the components that we're seeing is this concept of a knowledge base. And one thing to remember from when we talked about cloud computing is that AWS will rename things, and that's what makes things a little bit annoying, is that instead of something being called Spark, which is what Databricks uh, is offering as a service, they call it EMR. And so you're like, wait, what is EMR? Elastic Map Reduce. Yeah, but what is that? Well, it's Spark, right? So they rename things a lot. It makes things confusing. So likewise, if you go to the RAG solution, you're like, wait, where's AWS RAG? Well, it's in Bedrock. It's just called knowledge bases. And so a knowledge base, all it is just a vector database that can ingest some data. So you then, if you wanted to implement, and I'm going to talk about the technical theory behind the solutions on AWS. If you want to do it, pretty easy actually. All you have to do is click on the button for knowledge base. It'll ask you some questions, and then you give it a corpus of data. So you just put, if you want, some data into a bucket on S3, and then it will ingest it inside. And now you have a vector database that's ready to go. Now, one warning I will say about this is that it's super expensive to use the vector databases on AWS. So it could be $200 a month if you left it running 24/7. So be very careful about doing this unless you have a bunch of money in credits or something from AWS, but you could turn it on, then turn it off. But be careful, because even if it looks like it's been turned off, sometimes it's still running. So that's just in general, you have to be very, very careful with knowledge bases. But once you do that, you can just point and click, and then you have a knowledge base. Now, the next question is, well, okay, I'm using RAG, but like, how do I actually use it? So then the next thing to do would be that you can point some kind of service to the RAG database. And here's where we get into more practical use cases for RAG, and that's agents. So you may have heard the term of like, hey, we're building agents and we're building all this stuff. So unfortunately, just like how AI isn't AI, it's basically generative search, an agent isn't actually an agent, it's just a script. So instead of it being some super smart, intelligent thing that solves problems, um, really what's happening is that it's just a script that's really, really not that intelligent at all. It has no smarts, but you can put smarts into it by using some of these tools. So you could obviously pick a model that's got good capabilities of generative, again, I'll call it generative search. You have the RAG database that grounds it together. And then the agent itself, if you constrict the problem to something that, where again, you think about the Toyota way, where they kind of refine things, or you look at DevOps, they refine things so it's a small problem. If you give it a very specific problem to solve, that potentially could be something you could do with an agent, just as long as you understand that you have to constrain the problem so tiny that there's very little chance that it will fail. And that's the essence of software engineering, is reduce the complexity so it's not really possible for there to be problems. So one of the things that we could do, which we covered, I think it was maybe a week or two ago, I forget what it was, we covered potentially, could you build an agent that was a patching agent? So I do think you could build something like that. But again, it's not a robot, it's not intelligent, but it could be something that's automated. We've been doing automation with software engineering for a long time. Like we have a CI/CD is a good example, which you have a build system, and the build system can test your code automatically, and it can push the code to production. So you could say, well, wait a second, if I make a change to a website, like if I have a markdown file and the markdown file gets converted into HTML and I send that HTML over to a website, isn't that an agent? Right? Isn't that some kind of, sentient being? Well, no, it's not an agent. It's basically just a script that, given certain context, it will do certain things, right? So it's logic. So similarly with an agent, I think that's the way to think about it, is if you constrain the problem to, so that it's within the capabilities of what it could do, that is probably a good way to combine all these things together. Combine RAG, combine generative AI, all in one solution, and then make it into an agent. So AWS also does have that as well. They have the agent capability. So I would say, if we kind of put things together here, the way to prototype out using RAG and agents together would be to probably use something like AWS, use something that's off the shelf, so that you can leverage a company that has a lot of people who are focus on making the problem better. If you look at only like a AI vendor, a Gen AI vendor like Anthropic or OpenAI or somebody that's only only generative AI, Mistral or something, like I would be a little more skeptical that to build something around one of those companies. And the reason I would say this is that they're not a cloud computing provider. They don't have decades of experience building services that work 24/7. So it's probably a smarter move to look at the big picture and say, look, if I want to implement something like an agent, here's the checklist of things I should do. One, I should use a cloud vendor like Google Cloud, AWS Cloud, Azure Cloud, right? Like probably use a large vendor or maybe, I don't know, IBM Cloud or something. Use a very large cloud vendor. And then B, it's a good idea to constrain the problem to something that's initially very tiny. Like, for example, hey, look for bugs in my code and give me suggestions that are patches and test those patches to verify that they work, right? Like that seems like kind of a fun thing you could do, uh, as long as you don't get fooled by thinking because you automated something, it is logical or intelligent or it has those kinds of capabilities. And then three is, yeah, maybe wire together those components using off of the shelf tools with AWS. So that probably is a good place to to maybe focus on, in terms of like the theory behind RAG. Why do you care about it? What are the solutions that you can implement with RAG? So any questions about that? Does that make sense logically? So if you wanted to experiment yourself, I think the action items would be, uh, set up a billing alert on AWS to make sure that you're not going to get yourself in trouble. Be extremely careful with tearing down resources when you're done with them. But I think in terms of ROI and learning the technology, I think probably using the Bedrock lifecycle is one of the more mature life cycles to understand RAG, to understand agents, and to understand kind of some of the pros and cons of generative AI. And you can, of course, communicate with all of these services via their SDK, their software development kit, and you can actually build solutions that talk to those. So you could potentially build, if you wanted to build a prototype as your final project as a student to show people, hey, look, these are the kinds of things I know how to do. You should hire me. I think that would be kind of a compelling one, would be to build something that talks to Bedrock, maybe also does some RAG with their knowledge bases, and then you maybe create an agent, and the agent does something very, very tiny. I do have some code examples as well inside of the platform I developed that show you a lot of it in terms of building like things around the Bedrock ecosystem. But personally, I think that would be a pretty good type of portfolio project to build, is focusing heavily on the AWS Bedrock ecosystem, because you're constraining the problem in a way where the probability of you being successful is very high. If you only glue together like little pieces from here, little pieces from there, from different locations, and maybe work on something very complex, your demo is going to be less compelling, I think. And so maybe it's worth talking a little bit about portfolio projects in general, since I think that's maybe ties into some of the questions people were asking last week. And what does that mean, A, for RAG and generative AI, and then B, in the era of these tools? So one problem, well, first let's talk about before there was generative AI, what I would recommend for students to build projects, data science, machine learning students. And by the way, a lot of former students, I still they email me and say, hey, I got a job at Google or Amazon, etc. And I took your class and you told me about portfolios. So I've might as well talk a little bit about portfolios because we talked more about the low level cloud computing stuff, but now that we're getting more towards software engineering, I'll just briefly mention again, first before there was generative AI tools, what I would recommend to students, like if I was teaching a machine learning class. So one of the things I would recommend is that yeah, you have a project that solves an interesting problem. You have a README file that clearly documents what it is you're solving. It shows a description of what the problem is. You have a nice diagram that shows the architecture, like again, using maybe cloud architecture diagrams. And then potentially you also have, not potentially, you 100% have the steps to clone the project and then test the project and then deploy the project maybe in a different environment. So I think that those steps in the past have led students to getting jobs based on my experience in close to 10 years teaching. It was a very highly productive way for students to get jobs because you can clearly say the problem you're solving. Now, one problem that we face with these coding assistant tools is now a portfolio project is a lot less interesting because everybody can create a portfolio project because everybody can use these tools. So my advice for people who are doing, and want to get a job using, especially in the field of AI and generative AI, especially in the context of what we've learned from January to almost May now, is that I do still think you have to build a portfolio project. But here's the bad news. The bad news is that you need to make it much more complex and much more compelling, and there can be no weakness with your portfolio project. Before these tools existed, you are, like I said, there's a checklist, have a really good README, make sure you have tests where people can replicate your code and test it, make sure they can deploy it. Like these are kind of, we'll call them the checklist of best practices, like software engineering best practices. And that would be a signal to an employer, hey, look, this person is really thoughtful. Look at all the different things that they did. This is really the things that I have to do every day when I'm building software. This person is clearly the kind of person that I would want to hire at my company. That's why I would recommend students to do it. And like I told you, like I have a lot of students who have worked for them to get jobs. The difference, though, is now everybody can do that. So my recommendation is that you have to still do all those things, but you have to actually have no weakness. What it means is that the project that you build needs to have effectively 100% perfection in what you build. So I think having extremely good tests for your project, so, for example, having some unit tests that show that you've covered the code and you have logic that verifies it, having an integration test or an end-to-end test that tests, a payload going into, let's say it's an API that you built or a web application, you have a payload that goes in, it exercises the application, and then it returns back a result. That's what a real software engineer does. Like, for example, some of the stuff I've built even this year, I have maybe dozens of end-to-end tests. We call them smoke tests, where each component of the system is been exercised. So the way to describe it would be like a car. If you're building Toyota car, like a I don't know, a SUV or something, you would have tests for the tires, you'd have tests for the engine, you'd have tests for the emissions, you'd have tests for the electronic system, you'd have tests for the entire car, right? You would test each subcomponent, but you would also test the vehicle itself. So not only do you need to have logic tests that are unit tests, but you also need to have end-to-end tests for each component and then an end-to-end test for the entire system. So that's one way you could really differentiate yourself from other students who have portfolio projects, is that you're really thinking about quality control. and you're focusing on showing that you know how to build a system that leverages these generative AI coding assistants, not to do something that everybody else is doing, but to increase the quality of your project by writing more tests, more Indian capabilities. So that's one component is I would make sure you're testing, and you could just look into testing, right? Like what are the kinds of tests that are software engineers would do. So, and I'm telling you, unit tests, integration tests, and then smoke tests. And then finally, the fourth one would be a load test, which is in the real world, it's one thing to build something that works for 5 people, but in the real world, you want potentially to be able to use 10,000 or 100,000. We talked about this with cloud computing, right? Is that you're designing things to be elastic, right? So they have the ability to expand and contract. So how would you know unless you did a load test? And so you need to have a test that simulates under load, like how many requests per second, how many users could use your system, maybe even like a UX based load test as well, where you have a website where it pushes the button over and over again, and you can actually exercise the system to figure out the stuff that you're building. So that's another component of your portfolio project that I would look into. And then in terms of the monitoring, logging, and instrumentation, so if we look at some of those DevOps best practices that we covered in the Cloud Computing Foundations course, I also believe you would need to show that you have the ability to log, monitor, and instrument your project. So again, if you show someone a portfolio project that just does the logic, and let's say even it has some tests with it, like I recommended you write some tests, you have some tests with it, and maybe it's like something that talks to Bedrock and does RAG or whatever, and you have a test, like great. But if you can use these tools to help you generate code, why wouldn't you do the same things people are doing in a real world production environment to show that you should be somebody that works in their company? In the real world, you add monitoring and instrumentation to your code. So, what is monitoring and instrumentation? Let's go back to the vehicle. It's like if you're driving down the highway and you have no speedometer, how fast are you going? You could guess, but you're going to get a speeding ticket or you could crash. You need to have a gauge that tells you what's happening. That's monitoring and instrumentation, right? Is it's a logic based system. So likewise in your code, you need to have ways to instrument, hey, this is being called, this is what's happening, so that at the very end, you're able to show not only that the core components of your system have been built, but that the quality is at the exact same quality that a production system would be built. So if you're going to build, let's circle back to RAG because that's the thing we're trying to talk about. If you're going to build an agent or RAG or some kind of a solution, and I do recommend you build a portfolio project, I think the standards of excellence are critical when you're building this. Is like, what are your standards of excellence? And the standards of excellence would be what is a professional software engineer that works at Google or Amazon or Microsoft, like day to day. What do they do? Well, I know because I know these people. I've known them for decades. Is you have a README, you have tests, you have integration tests, you have monitoring instrumentation, and going back to cloud, you also have the ability to automatically deploy it. So do you have the infrastructure as code component so that you can push this into production? So on one hand, you could make the argument that, hey, it's going to be tough to get a job because there's so many people that can build portfolio projects. But I would say be careful to say that's the excuse for not getting a job, because that's not true that everybody can do the same thing. The devil is in the details. It's one thing to build a toy project that doesn't work. And there's a lot of people that are building toy projects that don't work. It's another thing to know what a real software engineer is doing and do those best practices yourself and show that you can do those best practices in your project. So as you're building your portfolio projects for AI, I think this is how you could really differentiate yourself, is to be very, very um, rigid about the quality of the thing you're building, and to make sure that you have, and you could use generative AI to give you some ideas of like, hey, what is a professional, what's a checklist of 10 things a professional software engineer does when they deploy a microservice that's a generative AI RAG based microservice to production. What are 10 things they would do? I bet you anything, all the things I told you over the last 45 minutes are what the thing's going to say, but that could be a good way to validate your assumptions as well. So um, I think it's worth circling that into what we're talking about theory before we get into the technical RAG next week.